Thanks, guys. So I'm going to talk about testing Vue apps and my approach to testing Vue applications. My name's Edd Yerburgh. I'm a software engineer at the BBC in London, and I'm also the main author of Vue Test Utils, which is a testing library for Vue. So you can find me on Twitter at Edd Yerburgh. So imagine that you've written an app. It's a really simple app that renders a modal when you land on the page, and you can dismiss the modal by clicking on a close button. So after you've written the code, before you send it into production, you probably want to check that it works correctly first. So you'd open up a browser, make sure that the modal's there, click on the close button, and then check that that does dismiss the modal. So what you've just done there is you've manually tested that your application's working correctly. And this works great when your app's small and doesn't have many features. But as an app grows larger, it becomes really time-consuming to manually check all of the features are working correctly. And this means that you probably won't do that, and you open up the risk of adding bugs to your project. So the solution is to use automated tests, which is basically writing code and using programs to do all of the checks on your application for you. So there are some big benefits to having automated tests run against your application. Firstly, you can check that the app's working correctly, which is really useful when you're working on a big team and you're reviewing a pull request. If you have tests running against it, you can be fairly confident that all of the features that were working previously are still working correctly. Another benefit is that writing tests is basically writing living documentation for your code. So when new developers come to a project and there are some test files, they can open up the test files to see exactly how the application works. Another really powerful benefit of automated tests is that you get this easy debugging cycle. So if you run your tests after you make changes to your code, and if your tests run quickly, you can find out really quickly that you haven't broken any existing functionality and everything's still working correctly. And ultimately, having tests leads to less bugs. So there are a lot of studies that have found that having tests in your code can reduce bugs in production by anywhere from 20 to 80%. But there are some downsides. So writing tests takes time, and usually the cost in time of writing tests is outweighed by the benefits you gain in being able to quickly check that your app's working correctly. But if you write tests poorly, you can end up in a situation where having a lot of tests actually slows down development. And for example, you might end up in a situation where changing something trivial in your app, like changing a span tag to a p tag, ends up taking a lot longer than it should be. So when we write tests for an application, we need to make sure that we avoid writing too many tests that tie us into an implementation and make it difficult to refactor our components. So this is my approach to testing applications. This is the front-end testing pyramid, and it's an adaptation of the testing pyramid that describes how your testing suite should be made up from different types of tests. So I'm going to walk through what each of these types of tests are and how we can write them in a Vue application. You can see that we have a few end-to-end tests, a few more snapshot tests, and then the bulk of the test suite are going to be made up from unit tests. So end-to-end tests, I think, are the most intuitive kind of tests to understand. Earlier, when we were manually checking the modal application, we opened up the browser, checked with our eyes that the modal existed, clicked on the close button, and then checked that it didn't exist anymore. So we could actually automate this and write some code that automates a browser to run through those actions and then check that the application responds correctly. And that's what an end-to-end test is. So the code for doing what we were doing earlier, manually testing the application, would look like this. We're going to open up a browser at the URL that our app is running on. Then we're going to wait till the page is loaded, click on the modal button, and assert that the modal isn't present anymore, that it doesn't exist. So great, we've automated away our manual testing. So you might be thinking, why don't we just write all of our tests like this? Why don't we just have end-to-end tests checking that our app's working correctly? Well, there's a couple of problems with end-to-end tests. Firstly, they're difficult to debug. So if the test that we just wrote failed, we wouldn't know if the problem was with the modal component or the page component or some other part of our code. Another big downside to end-to-end tests is that they're slow. So it's not uncommon to have an end-to-end test suite that takes 30 minutes to run. So we can't just rely on end-to-end tests to get the debugging benefits that we have from an automated test suite. That's where unit tests come in. So let's take an example. Let's look at a simple example of a unit test. So you have a sum module that exports a function that adds two parameters together and returns the sum of the parameters. And you want to check that this specific function is working correctly. So we can write a test file where we import sum and define a test with this test function. So this is added by the test runner that we're using. We'll be using Jest. And test takes a spec name, so we're going to check that it returns the sum of input. And we have the actual test function itself, where we call expect with the result of sum of 1 and 3. So expect returns matcher functions. Here we're using the 2b matcher that takes a value and then compares the value that the matcher was called with to the value that expect was called with. So basically we're checking that sum of 1 and 3 equals 4. And when we run Jest from the command line, it's going to go through our project, pick up this file, run the test, and if the sum of 1 and 3 equals 4, we're going to get a passing test. So we know that the sum function is working. If the sum of 1 and 3 doesn't return 4, we'll get a failing test. And this is really useful because it tells us that the problem's in the sum function, and using the assertion error, where we can see we had 3 instead of 4, we get a good idea of how we can fix the problem. So unit tests are really easy to debug because they're focused on a small part of your code base. And they're really fast. So while end-to-end tests take minutes to run, unit tests take seconds to run. Now you can write unit tests for Vue components, and in my Vue applications, most of the tests that I write are unit tests for Vue single file components. So here we're going to use VueTestUtils' mount method, which takes a component, mounts it, and returns a wrapper object that contains a reference to the component instance, as well as some helper methods to assert and traverse the component. So then we'll just, we're checking that the modal doesn't render anything. So we're just going to expect that wrapper.isEmpty will be true. So you might be tempted to start writing tests like this. So this test is checking that we're rendering a div with an A class somewhere in the component. And at some point you might want to change that class to another class. These kind of tests uh, are not valuable. So you could end up with 20 of these tests for each component. And when you want to change something, like refactor how you're rendering the component, how you're styling it, what elements you're rendering, it becomes really difficult. Okay, so if we're not going to write tests that check just the output, what tests are we going to write? So the way that I decide what unit tests I should write for a component is by using this idea of a component contract. A component contract is the API or the interface that your component has. So it's the details that a user would need to know in order to use your component in an application. I like to think of it as if I was going to write a page of documentation about a component, the details that I put in that documentation are part of its contract. So if you test by thinking about a component's core contract, you focus on what input you pass into a component, and then you'll assert against the output that the component generates, and treat the component as a black box, which means that you're free to refactor the component and change the implementation details without having to rewrite your tests. So for a few components, the input could be a user action like clicking on a button, or the props that are passed down to a component, or it could even be providing a Vuex store with the correct state. And the output that you'll be asserting against, it could be the rendered output. So there isn't anything wrong with checking the rendered output. But you just don't want to write tests like I showed you earlier, where you're just rendering a component and just checking that it renders a div without providing any extra input. Another form of output could be a view event. So a component could dispatch a view event. And another form of output that I often find myself testing are function calls. So committing a Vuex mutation, that's a form of output that you can test. So when we write unit tests using the component contract, we need to decide what the API is before we write the tests. So for our modal component, the API looks like this. We're going to have a visible prop that takes a Boolean, and if it's true, it will render. If it's false, it won't. It'll take an onClose property, which is a function that will be called when the close button is clicked. So I can already think of some tests we could write for this that cover the core contract of that component. We could check that it calls onClose when a button is clicked, or that it doesn't render when passed a visible prop, or that it does render when passed visible prop set to true. So this is the core functionality of that component, and we arrived at it by deciding on what the API of the component was going to look like. And once we've written code to pass these tests, we'd end up with something like this, which obviously isn't actually very useful. This isn't going to be styled correctly, it's just a div with a button. But what this does contain is all of the logic that the finished component is going to have. So all of this here is tested by unit tests, tested by unit tests. So at this point I would stop writing unit tests for the component and go ahead and write the styles. So after writing the styles, it would look a bit more like this. And there's a lot of untested code here, but it's untested static code. So there's no logic that we need to test. And part of styling a component is you're inherently going to be manually testing the component. Unless you're an absolute genius at CSS, you probably have to check your component after you've written the CSS and written your elements. But if you're like me, you probably want to have some kind of test to make sure that you don't accidentally delete a div and break the styling of the component. And that's where snapshot tests come in. So snapshot tests take a snapshot of a component, and then each time they're rerun, they'll take a new snapshot and compare it against the previously saved snapshot. So we're going to write a Jest snapshot test. We'll create a wrapper by using the VueTestUtils mount method, and we're going to pass in props data with visible to true so that the component renders. And then we're going to call expect with the result of the HTML method, which returns a string of the inner HTML of the component, and use this toMatch snapshot matcher. So the toMatch snapshot matcher will tell Jest to run a snapshot test. So when Jest runs this, it's going to go through this logic. Firstly, it checks if a previous snapshot exists. If it doesn't, it will create a snapshot and the test will pass. If it does, it will compare the value that expect was called with to the saved snapshot test. And when it does that, if the output that it was called with matches a snapshot test, the snapshot test will pass. If it doesn't, the test will fail. So I'm going to do a demo to show you guys what this looks like in practice. So here we're in a test file, and we're just going to define a test, check that it renders correctly. And then we need to create a wrapper by calling mount with modal, pass in the props data with visible set to true, and then expect that the wrapper.html and use the toMatch snapshot matcher. So now we can run Jest, and it's going to find that file, run the test, and then write a snapshot. So if we look back in the project, we can see that this snapshots directory has been generated by Jest. And if we open up the file, it's taken the the string that expect was called with, formatted it, and saved it in this file. So if we run the test again, Jest is going to compare the value that expect was called with and compare it to the snapshot test, and the test will pass because the output is still the same. If I accidentally deleted a class and ran my tests again, the snapshot test is going to fail, and it's going to show us this diff. So we can see that we accidentally deleted the class, and we can add it back in, run the test, and the test will pass. And then if we did actually want to add in an extra class, when we run the snapshot test, it's going to fail because it's comparing it against the old output, which didn't have that extra class. But we can tell Jest to update the snapshot by calling it with this, by running it with this U flag, which is an alias for update snapshots. So we've really quickly updated our test, the snapshot test. So snapshot tests basically safeguard against any unintended changes that we might make to a component. And they're really quick to update. So it works well with styling. Because if you make a lot of changes, you're going to be checking manually in the browser that it's styled correctly. And then you can just quickly update your snapshot test to match the new output of your component. So yeah, we've now gone through each of these types of tests. If we look at the front-end testing pyramid again, you can see that the bulk of our tests are made up from unit tests, which run really fast, are easy to debug, and are just testing the core functionality of our components, which we decided by using the idea of a component contract. Then we're going to use snapshot tests to test the style and make sure we don't accidentally regress any of the components. And finally, we'll run a few end-to-end tests, because unit tests are only checking units of our code. They're not checking that they're all working together. So if we have a few end-to-end tests that just run through the core user journeys, it's going to supplement our unit tests and make sure that the application's working together. So if you want to learn more about testing, there's a really great book out right now called Testing Vue.js Applications, written by me. And you can get 40% off with this code just for you guys at the conference, CTW VueConf US 18. So if you want to take a picture and use that code later, now's the time to do it. Okay, thanks guys. Thanks for listening.